Hello, and welcome to Architect of Sleep. Tonight, we are leaving the noisy world behind to travel to a quiet ocean of stars and silence. It is a place where light travels for millions of years just to reach your eyes, a place where whole worlds are born from dust and fade away like a dream. For now, just breathe, let your eyes grow heavy, and allow your mind to soften. Our journey begins now. In the deep quiet of space, there is a constant traveler. It is a silent runner that never stops and never slows down. This traveler is light, and it moves faster than anything else in the entire universe. Its speed is a number so large, it feels like a dream. Almost 300,000 kilometers for every single tick of a clock, every second. Imagine for a moment a race around our world. A fast jet airplane would take nearly 2 full days of constant flying to circle the Earth just once. But a beam of light, in a single second, could make that same journey more than 7 times. A flash of energy wrapping around our planet in less time than a heartbeat. This is not just a record to be broken. It is a fundamental law of the cosmos, the ultimate speed limit. It is a constant, a rule that is the same everywhere, a silent, unbreakable law written into the fabric of reality itself. Because of this incredible speed, looking up at the night sky is like looking into the past. The light you see from the stars is not as it is right now, but as it was when it began its long journey to you. The light from our own sun, our closest star, takes about 8 minutes and 20 seconds to reach us here on Earth. This means if the sun were to suddenly vanish, we would not know for over 8 minutes. We would continue to see its light and feel its warmth, like the ghost of a star that was already gone. The light from the next nearest star system, Alpha Centauri, takes more than 4 years to arrive. The light from the beautiful Andromeda galaxy has been traveling for 2.5 million years just to greet your eyes tonight, a silent gallery of ancient history. To measure these huge distances, astronomers use a special kind of ruler. It is a unit called a light year. This is not a measure of time, as its name might suggest, but a measure of immense distance. It represents the total distance that a single beam of light can travel through the vacuum of space in one single Earth year. This journey covers nearly 10 trillion kilometers, a number so large that our minds can barely hold it. It is like trying to imagine a measuring tape that could stretch from your home to the sun and back again, more than 30,000 times. It is a yardstick born of patience, a way for our small minds to comprehend the sheer scale of the quiet emptiness and our tiny place within it. The air around you on Earth feels light, almost empty, but the space between the stars is far, far emptier than we can imagine. The vast expanse between worlds and galaxies is a near-perfect vacuum, a state of profound and deep emptiness. If you could take a box the size of a large room and place it in the deepest space between galaxies, you would be lucky to find even a few stray atoms of hydrogen inside. Here on Earth, that very same box is filled with trillions upon trillions of air molecules, all bumping and moving and carrying sound. But out there is an almost perfect stillness, a silence that stretches on for eternity, a quiet so deep it has no opposite. And in this profound silence, there is no sound. Sound as we know it is a vibration, a wave that needs something to travel through, like air or water or solid ground. The vibrations travel from molecule to molecule, like a ripple spreading across a pond. In the near-perfect vacuum of space, There are not enough molecules to carry these vibrations. A star could explode in a brilliant flash right next to you, an event of unimaginable power, and you would hear absolutely nothing. There would be no bang, no roar, just a silent, blinding flash of light against the endless dark. The universe performs its greatest and most violent dramas in complete and total silence, a quiet theater of light and gravity. While there is no sound, astronauts who have ventured into space have noticed a strange and distinct smell. It is a faint scent that clings to their spacesuits and equipment when they return inside the space station after a spacewalk. They describe it in different ways. Some say it smells like hot metal or the sharp scent of welding fumes. Others have compared it to seared steak or burnt almonds and raspberries. This is the faint scent of the universe itself, caused by energetic particles and chemical reactions in the void. It is the smell of dying stars and atomic oxygen, the faint metallic trace of the cosmos clinging to them, a strange souvenir from the great emptiness. And in that vast void, the temperature is incredibly cold. Far from the gentle warmth of a star, the baseline temperature of deep space is just a few degrees above absolute zero. This point, at minus 273.15 degrees Celsius, is the coldest anything can possibly be, the point at which all atomic motion nearly ceases. It is a fundamental limit of nature, a point of ultimate stillness and rest. Without a star to warm it, any lost object would slowly radiate away all its heat, growing colder and colder over millions of years, until it matched the deep chill of the universe around it, becoming a silent, icy wanderer, frozen in the endless night. Our sun is one of these warming stars, a great furnace in the sky that holds back the cosmic cold for our small family of planets. It is the very center of our solar system, the anchor that holds us all together. To us, it seems huge and powerful in our sky, a unique and brilliant god of light and warmth. But in the grand scheme of the universe, our sun is just an average star, a common medium-sized yellow dwarf. It is just one of billions and billions of stars in our galaxy alone, a gentle yellow fire in a sea of countless others, each with its own story, its own potential for worlds. The sun is so large that our minds struggle to picture its true scale. You could fit more than 1 million planet Earths inside of it, and still have plenty of room to spare. If the Earth were the size of a small pebble, the sun would be a giant glowing ball more than 5 feet wide. It is a giant churning sphere of incredibly hot gas. Mostly simple elements like hydrogen and helium, its immense mass creates a powerful gravitational pull, an invisible force that reaches out across billions of kilometers, an unbreakable tether. It is this gravity that holds our world, and all the other planets, in their gentle, predictable orbits, a constant invisible hand guiding us through the darkness. Every single second, the sun performs a quiet miracle in its core. It converts millions of tons of its own matter into pure energy. In its heart, the pressure and temperature are so extreme that hydrogen atoms are squeezed together with unimaginable force, fusing to become helium. This process, called nuclear fusion, releases a tremendous amount of energy. This energy, in the form of light particles called photons, travels outward for thousands of years to reach the sun's surface, and then flies across space to us as light and heat. It is this constant, steady gift from our nearest star that warms our world, powers our weather, and makes all life on Earth possible. But our sun, like all things, will not burn forever. It has been shining steadily for about 4.5 billion years, and scientists calculate that it has enough hydrogen fuel to continue for about another 5 billion years. When its hydrogen fuel begins to run low in its core, it will start a slow and dramatic transformation. It will begin to swell, puffing its outer layers outward, becoming what is known as a red giant. It will grow larger and larger, and its surface will become cooler and much redder. A slow, final breath that will expand to swallow the inner planets of Mercury and Venus, and perhaps even reach the Earth itself. After its long time as a bloated red giant, the Sun's core will be all that remains of our star. The outer layers will have drifted away gently into space, forming a beautiful glowing cloud of gas called a planetary nebula. The hot, dense core left behind will become a white dwarf. This will be an amazing object, a star about the size of the Earth, but with nearly the entire mass of our Sun packed inside it, making it incredibly dense and incredibly hot. It will no longer create new energy through fusion. It will simply be a cooling ember, shining with leftover heat from its former life, a fading diamond in the cosmic night. Eventually, after an almost infinite amount of time, that white dwarf will have radiated all of its heat away into space. It will slowly cool down and fade over trillions and trillions of years, a period of time far longer than the current age of the entire universe. It will finally become a black dwarf, a cold, dark, invisible object that no longer gives off any light or heat at all. It will be a solid crystal of carbon and oxygen, floating silently in the eternal darkness. It will be the final quiet monument to a star that once gave life to a world, a cold gravestone in the graveyard of space. Some stars, the ones much more massive than our Sun, end their lives in a much more dramatic and spectacular way. When a very large star runs out of nuclear fuel, its core can no longer produce the outward pressure needed to fight against the crush of its own immense gravity. The star collapses in on itself in a fraction of a second, a catastrophic implosion. This collapse triggers a huge rebounding explosion called a supernova. For a few weeks, this single exploding star can outshine its entire home galaxy of 100 billion stars, a brilliant final flash of glory before it fades away from view forever. These supernova explosions are cosmic forges. They are where most of the heavy elements in the universe are made. The simple hydrogen and helium from the Big Bang can only be fused into heavier elements, like carbon and oxygen, inside the intense hearts of stars. But the heaviest elements of all, like the gold in a ring, the silver in a coin, the uranium in the earth, are only created in the unimaginable heat and pressure of a supernova explosion. The atoms that make up your body, the iron in your blood and the calcium in your bones, were all forged in the heart of an exploding star, long, long ago. We are all made of stardust, the quiet children of long-dead suns. The most common thing in the entire universe is a simple element called hydrogen. It is the simplest atom of all, with just one tiny proton in its center and one electron orbiting it. It was the very first element to form after the Big Bang, when the universe was young, hot, and dense. For millions of years, the universe was made of nothing but vast, dark clouds of hydrogen and a little bit of helium. This humble hydrogen is the primary fuel for all stars, and it is the fundamental building block for every other element, and for everything we see around us. A simple, quiet beginning for all cosmic complexity. After a supernova explosion scatters a star's outer layers across space, sometimes the crushed core of the star survives the blast. If the original star was large enough, but not too large, the core becomes something called a neutron star. These objects are among the densest things in the entire universe, packing the mass of our sun, or even more, into a tiny ball only about 20 kilometers, or 12 miles, wide. Imagine the entire weight of our sun, squeezed down into a sphere the size of a single city. The gravity on its surface would be billions of times stronger than Earth's, a place of unimaginable forces, a tiny, heavy remnant of a giant star. The material of a neutron star is so dense that it is unlike anything we know or can create on Earth. The gravity there is so powerful that it crushes atoms themselves. Protons and electrons are forced to merge together, becoming a substance made almost entirely of neutrons, packed tightly together like marbles in a jar. A single spoonful of this neutron star material would weigh more than all the cars on Earth combined, billions of tons. It would be like taking a mountain like Mount Everest and compressing it into a space smaller than a grain of sugar, a solid sea of unimaginable weight. But if the original star is even more massive, its collapse does not stop at a neutron star. Gravity wins the final battle completely and absolutely. The core continues to crush down and down and down, getting smaller and denser until it becomes a point of infinite density, a single point with no volume at all, called a singularity. This creates a black hole, an object with a gravitational pull so strong that nothing can escape its grasp, not even light itself. It is a tear in the fabric of space and time, a place where the known laws of physics break down completely, a quiet waterfall into darkness. Around every black hole is a mysterious boundary. It is called the event horizon. This is not a physical surface that you could touch, but rather an invisible point of no return, an invisible border in space. Once any object, or any beam of light, crosses this line, it is pulled inward forever. It cannot turn back. It cannot escape, no matter how fast it tries to travel. The gravity is simply too strong. It is like a river that flows gently at first, but then quickens until it becomes a great waterfall, and the event horizon is the very edge of that fall, beyond which there is only the silent plunge into the unknown. You cannot see a black hole directly because by its very nature, it swallows all light that falls into it, making it perfectly black. It is like a perfect shadow, cast against the bright backdrop of space. So we must find them indirectly, by watching their powerful effect on the things around them. We can see stars orbiting what appears to be an empty point in space, held in a fast, tight gravitational dance with an invisible partner. Or we can see gas and dust being pulled in, heating up and glowing with brilliant X-rays as it spirals faster and faster towards the event horizon, a final bright scream before it disappears into the silence. Our own galaxy, the vast city of stars we call the Milky Way, has a giant black hole at its very center. It is named Sagittarius A, pronounced Sagittarius A star. This black hole is a true monster, a supermassive black hole. It has the mass of 4 million suns, all contained within a single invisible point. All the hundreds of billions of stars in our galaxy, including our own sun, are slowly and gracefully orbiting this distant massive object over millions of years. But there is no need to worry. It is very, very far away, about 26,000 light-years from us. and our solar system is in a safe, quiet spiral arm of the galaxy, like a peaceful suburb of a great swirling cosmic city. This city of stars, our Milky Way, is a beautiful spiral galaxy. It is a vast, spinning disk of stars, gas, and dust, about 100,000 light-years across from one side to the other. If you could see it from above, it would look like a magnificent glowing pinwheel with long, graceful arms curling out from a bright central hub. Our Sun is just one of at least 100 billion stars in this single galaxy, and some estimates say it could be as many as 400 billion. It is a single grain of sand on an endless, glittering beach, a quiet and common star in a vast metropolis of light. Our whole solar system is in constant motion. We are not sitting still in space, not for a moment. We are orbiting the center of the Milky Way galaxy, traveling at an incredible speed of about 800,000 kilometers per hour, or 500,000 miles per hour. Even at this breathtaking speed, it takes our Sun and all its planets about 230 million years to make one single complete trip around the galaxy. This long journey is sometimes called a cosmic year. The last time our solar system was in this exact position in its orbit, the first dinosaurs were just beginning to walk the Earth, a long, slow, silent dance through the stars. And our galaxy is not alone in the vastness. It is part of a small, local cluster of galaxies, which astronomers have named the Local Group. This group contains our Milky Way, another large galaxy called Andromeda, and more than 50 smaller dwarf galaxies, all bound together by their mutual gravity, like a small cosmic family. Our nearest large neighbor is the Andromeda Galaxy. It is a fellow spiral galaxy, slightly larger than our own, and it is a faint fuzzy patch you can see in the autumn night sky with your own eyes. If you are far from the bright lights of the city, the most distant object visible to the naked human eye. The Andromeda Galaxy is slowly, but surely, moving towards us. It is closing the distance between us at a speed of about 110 kilometers per second, or about 400,000 kilometers per hour. In about 4.5 billion years, our two galaxies will begin to merge and collide. This will not be a violent crash like a car crash, because the space between individual stars is so incredibly vast. Instead, the two galaxies will pass through each other like ghosts, their stars mingling and their spiral shapes distorting over hundreds of millions of years. They will eventually settle into one, even larger elliptical galaxy, a slow and silent cosmic merger, creating a new giant island of stars. For a long time, we thought the Milky Way was the entire universe, that all the stars and faint smudges we could see were all there was. Then, in the 1920s, an astronomer named Edwin Hubble made a profound and universe-shattering discovery. He realized that the faint, fuzzy patches in the sky, which were called spiral nebulae, were not clouds of gas inside our own galaxy, as was believed. They were other galaxies, entire islands of stars, just like our own, but incredibly, unimaginably far away. In that moment, the known universe expanded from one single galaxy to countless others, and our place in it became much, much smaller and much more profound. There are perhaps 2 trillion galaxies in the part of the universe we can see, the observable universe. This is a number that is almost impossible for our minds to truly hold. It is more galaxies than there are grains of sand on all the beaches and in all the deserts of our entire planet combined. And each one of these distant galaxies is filled with billions, or even hundreds of billions of stars. Each one is a distant, ancient world of light, a universe of universes, stretching out in every direction, as far as our most powerful telescopes can possibly see. A humbling and quieting thought. One famous photograph shows this incredible number in a single tiny frame. It is called the Hubble Deep Field. In 1995, astronomers pointed the Hubble Space Telescope at a tiny, seemingly empty patch of the night sky. A spot in the darkness as small as a grain of sand held at arm's length. They let the telescope stare at this one spot for over 100 hours, collecting the faintest, most distant light imaginable. And in that tiny, dark spot, they found not emptiness, but over 3,000 distinct galaxies, each one a swirl of ancient light, some from the very dawn of time, a window into the deep past. And all of these countless galaxies are moving away from each other. The universe itself is expanding. It is not expanding into some empty space that is already there, but rather the very fabric of space itself is stretching, everywhere at once, all the time. A simple way to picture this is to imagine tiny dots drawn on the surface of a balloon. As you inflate the balloon, every dot gets further away from every other dot, not because they are moving across the balloon's surface, but because the rubber surface itself is expanding between them, a gentle, constant, and universal growth. We know that the universe is expanding because of something called redshift. It is a phenomenon similar to how the sound of a siren changes pitch as it moves away from you, a high pitch as it approaches, and a low pitch as it recedes. As a galaxy moves away from us, the light it emits is stretched by the expansion of space. This stretching shifts the light's wavelength towards the red end of the spectrum, so it appears redder than it should be. The further away a galaxy is, the faster it is moving away from us, and the more its light is red-shifted, the quiet, colorful evidence of a universe in constant motion. This expansion of the universe suggests a fascinating and powerful origin. If everything is moving apart now, it means that in the distant past, everything must have been much closer together. If you run the clock of the universe backwards, all the matter and energy in the entire observable universe was once contained in a single, hot, incredibly dense point, smaller than an atom. This idea is called the Big Bang theory. It states that about 13.8 billion years ago, the universe began to expand rapidly from this single point, and it has been expanding and cooling ever since, a moment of creation that is still unfolding all around us. In the very first moments after the Big Bang, the universe was a blindingly hot and dense soup of energy and tiny subatomic particles. It was hotter than the core of any star, and filled with a brilliant uniform light. As it expanded rapidly, in a period called inflation, it began to cool down. Within the first 3 minutes, this cooling allowed the first stable atomic nuclei to form from the particle soup, mostly hydrogen and helium. These simple elements were the seeds of everything we see today. All the stars, all the galaxies, and all the worlds were born from this simple, hot beginning. There is a faint echo of this fiery beginning all around us, filling all of space, no matter where we look. It is called the cosmic microwave background radiation, or the CMB. It is a faint, uniform glow of microwave light that comes from every direction in the sky, with a temperature of just 2.7 degrees above absolute zero. This is the leftover heat, the afterglow of the Big Bang itself. It was once incredibly hot and bright light, but over 13.8 billion years of cosmic expansion, It has stretched and cooled down to this faint whisper, the oldest and most ancient light in the universe, a baby picture of the cosmos. All of this space, all these stars and galaxies, are part of what we call the observable universe. This is the part of the universe from which light has had enough time to reach us since the Big Bang began 13.8 billion years ago. Because light travels at a finite speed, there is a horizon, a boundary beyond which we cannot see. We do not know what lies beyond this edge, or if the universe goes on forever, or if it is finite. It could be that space stretches on infinitely, or it could be that there are other universes entirely separate from our own, a great mystery at the edge of our sight. But even the universe that we can see is mostly a mystery to us. The stars, the galaxies, the gas and dust, all the things we can see with our telescopes, which physicists call baryonic matter, make up only about 5% of the total mass and energy in the universe. The rest, the other 95%, is made of two invisible and mysterious substances that we call dark matter and dark energy. The universe we see, the universe of light, is just the foam on the surface of a vast hidden ocean, the hidden scaffolding of the cosmos. One of these great mysteries is called dark matter. It does not give off any light or energy, and it does not interact with light in any way, which is why we call it dark. We cannot see it with any kind of telescope, whether it detects visible light, radio waves, or X-rays. It is completely invisible to us, but we know it must be there because we can see its powerful gravitational effects. It is the invisible glue that holds individual galaxies and entire clusters of galaxies together, providing the extra mass needed to keep them from flying apart as they spin. A silent, unseen shepherd guiding the cosmic dance of stars. Dark matter makes up about 27% of the universe, more than 5 times the amount of all the normal matter we can see combined. We believe it forms a vast invisible web, or scaffolding, that stretches throughout all of space. Galaxies and stars are not spread randomly. They are built within the densest parts of this invisible web, like dewdrops forming on a spider's silk in the cool morning air. This hidden architecture guided the formation of all the large-scale structures we see in the cosmos today, a silent foundation for everything that exists. The rest of the universe, a huge 68%, is made of something even more mysterious and strange. It is a force we call dark energy. It is not matter, but rather a strange pressure, a repulsive force that seems to be pushing everything apart. It is the perfect opposite of gravity. While gravity is an attractive force that pulls things together, dark energy is a repulsive force that pushes them away. It is this dark energy that is causing the expansion of the universe to speed up, to accelerate over time. A gentle, constant push against the pull of gravity. We do not know what dark energy is. It is one of the biggest and most profound puzzles in all of modern science. It seems to be a property of empty space itself, an intrinsic energy hidden in the vacuum. This means that even in the emptiest parts of the void, where there is no matter at all, there is this quiet, persistent energy that is slowly stretching the fabric of the universe. It is this mysterious force that will likely determine the final fate of our universe, whether it will expand forever until it is cold and dark, or end in some other, more dramatic way. A quiet energy that holds the future in its hands. Gravity itself, the force we know best from our daily lives, has some strange and wonderful properties of its own. Albert Einstein's theory of general relativity showed us that gravity is not a force in the traditional sense, like magnetism or a push. It is a curvature, a bending of the fabric of space-time itself. Massive objects like stars and galaxies create deep dents or wells in this four-dimensional fabric. Smaller objects, like planets, are not being pulled by a force. They are simply following the straightest possible path through this curved space, like a marble rolling around the curved edge of a bowl. A new way of seeing the silent dance of the cosmos. This bending of space-time by massive objects has a visible and beautiful effect. It can bend the path of light itself. This effect is called gravitational lensing. When light from a very distant galaxy passes by another massive galaxy or a giant cluster of galaxies on its way to us, its path is bent by the curvature of space around the massive object. This can create strange and beautiful distortions in the images we see with our telescopes. We might see multiple copies of the same distant galaxy, or its light might be smeared into long, glowing arcs and rings, a cosmic funhouse mirror created by the gentle weight of invisible matter. Sometimes, truly huge cosmic events, like the collision of two black holes or two neutron stars, create ripples in the fabric of space-time itself. These are called gravitational waves. They are like the ripples on the surface of a quiet pond after you throw in a stone. But instead of water, it is the very reality of space and time that is waving and stretching. These ripples spread out through the universe at the speed of light, carrying the story of their violent birth across billions of light years. A tremor in the fabric of reality. A silent echo of a cosmic crash. In recent years, we have built incredibly sensitive instruments here on Earth that can detect these tiny, tiny ripples. These detectors, called LIGO and Virgo, are L-shaped tunnels several kilometers long. They use lasers to measure a distance so precisely that they can detect a change smaller than the width of an atom. When a gravitational wave passes through Earth, it stretches and squeezes space by this tiny amount. When converted into sound, the signal makes a simple rising chirp sound that lasts for less than a second, a faint, ghostly whisper from a cosmic dance. Some of those dense neutron stars, the tiny, city-sized remnants of supernovae, spin very, very fast. These are called pulsars. They can rotate hundreds of times every single second, faster than the blades of a kitchen blender. As they spin, their powerful magnetic fields shoot out beams of radiation, like radio waves, from their magnetic poles. If one of these beams happens to sweep across the Earth as the star rotates, our radio telescopes see a regular, repeating pulse of energy. It is like a great lighthouse in space, flashing its light across the cosmic ocean, a silent, spinning beacon in the deep dark. The pulses from these pulsars are incredibly regular and unbelievably precise. Some of them are more accurate than our best atomic clocks here on Earth, keeping time with near-perfect regularity for millions of years. Scientists can use the precise timing of these pulses to study the space between the stars and to test the laws of physics in the most extreme conditions imaginable. They are natural clocks, scattered across the galaxy by ancient explosions, each one a tiny, spinning heart, beating with a steady rhythm in the deep quiet of space. Some of the brightest and most distant objects in the entire universe are called quasars. When they were first discovered in the 1960s, they looked like single faint stars in optical telescopes, which is why they were named quasi-stellar radio sources, or quasars. But we now know they are not stars at all. They are the incredibly luminous and active centers of very distant, and therefore very young, galaxies. A single quasar can be trillions of times brighter than our sun, shining with a brilliant, steady light that can be seen from across the observable universe, a beacon from the dawn of time. A quasar is powered by a supermassive black hole that is actively and hungrily feeding on huge amounts of gas, dust, and even entire stars that wander too close. As this material is pulled towards the black hole by its immense gravity, it forms a massive swirling disk around it called an accretion disk. The incredible friction and pressure within this disk heat the material up to millions of degrees, causing it to glow with an intensity that outshines the entire host galaxy. It is the final brilliant scream of matter as it spirals into the darkness of the black hole, a cosmic bonfire at the edge of time. Closer to home, our own solar system has its own quiet wonders. Between the orbits of the rocky inner planets like Mars and the gas giants like Jupiter, there is a wide ring of rocky objects. This is the asteroid belt. It contains millions of asteroids of all shapes and sizes, from tiny pebbles and grains of dust to large objects hundreds of miles across, like the dwarf planet Ceres. These are the leftover building blocks from the formation of our solar system, about 4.5 billion years ago. A field of ancient stones floating in the dark, a river of rock flowing silently around the sun. These asteroids are the remnants of a planet that never was. During the chaotic early days of the solar system, the immense gravity of the newly formed planet Jupiter stirred up this region of space with its powerful gravitational nudges. Its influence was too strong and too chaotic for these rocky pieces to come together and form a single, large planet. They remain as a silent, scattered reminder of our solar system's chaotic and violent past, a cosmic rubble field, orbiting the sun in a cold, patient loop for billions of years. Beyond the orbit of the most distant planet, Neptune, there is another, much larger and more spread-out ring of icy objects. This is called the Kuiper Belt. It is a vast, frozen frontier at the edge of our planetary system, a dark and frigid realm. It is home to several dwarf planets, including the famous world of Pluto, and countless smaller icy bodies which are like dirty snowballs made of frozen water, methane, and ammonia. The Kuiper Belt is like a second, much larger asteroid belt, but it is made of ice instead of rock, a dark, cold realm of forgotten worlds. And even further out, surrounding our entire solar system like a giant spherical shell, is a vast theoretical cloud of icy objects. This is called the Oort cloud. It is incredibly far away, extending almost a light year from the Sun, nearly a quarter of the way to the nearest star, Alpha Centauri. This vast cold shell marks the very edge of the Sun's gravitational influence. It is thought to contain trillions of icy bodies, each one in a slow, lazy orbit that can take millions of years to complete. A great invisible sphere of sleeping comets, the final frontier of our solar system. This distant Oort cloud is where most long-period comets come from. For billions of years, these icy bodies drift in the absolute cold and darkness, untouched and unchanged. But sometimes, the gravitational pull of a passing star or a gentle tidal force from our galaxy itself gives a small nudge to one of these icy bodies. This tiny push can be enough to knock it out of its stable, distant orbit and send it on a long, slow journey towards the inner solar system, a journey that can take millions of years. A sleeping ice ball awakened from its long slumber to visit the Sun. As a comet gets closer and closer to the Sun, its quiet journey becomes much more active and beautiful. The sun's warmth begins to heat up the icy nucleus, causing its frozen gases to turn directly into a vapor, a process called sublimation. This gas, along with dust that was trapped in the ice, forms a large glowing cloud around the comet's solid core. This cloud is called the coma, and it can grow to be larger than a planet like Jupiter. It is the comet's temporary atmosphere, a hazy, often greenish glow in the darkness of space, a sign of its awakening in the sunlight. The solar wind, a constant stream of charged particles flowing outward from the sun, then pushes this gas and dust away from the comet. This forms the long, beautiful tails that we associate with comets. Comets actually have two distinct tails, a bluish tail made of ionized gas that is pushed directly away from the sun by the solar wind's magnetic field, and a whiter, curved tail made of dust that follows a slightly different path along the comet's orbit. The tail of a comet is a temporary jewel in our night sky, a ghostly visitor from the cold, outer reaches of our own solar system, a fleeting spectacle of light and ice. A comet's tail, or tails, always point away from the sun. This is true no matter which direction the comet itself is traveling in its orbit. The pressure of sunlight and the force of the solar wind are much stronger than the comet's own forward motion. So the tail acts like a celestial windsock in a constant, gentle breeze, always showing the direction of the sun's influence. This means that even as the comet swings around the sun and begins to head back out into deep space, its tail will stream out in front of it, always pointing away from the light, a beautiful and counterintuitive truth. When small pieces of rock or dust from space, often debris left behind by a passing comet or asteroid, enter Earth's atmosphere, they create a beautiful fleeting sight. They are traveling at such high speeds, many kilometers per second, that the friction with our air causes them to heat up and burn with a brilliant light. This creates a bright streak of light across the night sky, which we call a meteor, or more poetically, a shooting star. It is not a star at all, but a tiny piece of cosmic dust, offering a final, brilliant flash of light as it vaporizes, a silent, momentary farewell. Most of the meteors you might see on a clear night are caused by particles no bigger than a grain of sand or a small pebble. They burn up completely in the upper atmosphere, many miles above the ground, and never reach the surface. But if a piece is large enough to survive its fiery journey through the air and land on the Earth's surface, it is then called a meteorite. These are precious visitors from another world, pieces of asteroids or other planets that we can hold in our hands. They are a physical connection to the vast universe beyond our sky, a piece of another world, resting in our own. We have sent our own visitors out into the great expanse. The Voyager 1 and Voyager 2 probes were launched in 1977 on a grand tour of the outer planets of our solar system. After completing their missions to Jupiter, Saturn, Uranus, and Neptune, they continued to travel outward into the unknown. Voyager 1 has now traveled so far that it has crossed the boundary where the sun's influence ends and has entered interstellar space, the empty space between the stars. It is the first human-made object to do so, a silent, lonely ambassador sent from our small world to the great galactic ocean. Both Voyager probes carry a special message for any intelligent civilization that might one day find them drifting in the dark. It is a golden record, a phonograph record made of gold-plated copper, designed to last for 1 billion years in the cold of space. It contains sounds and images selected to portray the diversity of life and culture on Earth. There are greetings in 55 different languages, music from many cultures and eras, and 115 images of people, animals, places, and scientific diagrams, a message in a bottle thrown into the cosmic ocean, a hopeful whisper into the great void. While our solar system is full of planets, moons, and asteroids, it is important to remember that most of space is just that, space. The average distance between stars in our neighborhood of the galaxy is about 5 light-years. That is a vast and lonely distance, nearly 50 trillion kilometers. If our sun were the size of a grapefruit in New York City, the nearest star, Proxima Centauri, would be another grapefruit in San Francisco. The space in between would be almost entirely empty, filled with a quiet, patient, and profound darkness, an ocean of emptiness between tiny islands of light. This apparent emptiness is not truly empty, though it is very, very close. It is filled with a thin, wispy substance called the interstellar medium, which is made of extremely sparse gas, mostly hydrogen, and tiny, solid particles of cosmic dust. It is also filled with a constant rain of high-energy particles called cosmic rays. These are not rays of light, but the nuclei of atoms, mostly protons, that have been accelerated to near the speed of light by powerful events like supernova. They travel across the galaxy for millions of years, a constant invisible rain of energetic particles falling on our world from every direction. Our planet has a wonderful invisible shield that protects us from most of these cosmic rays and from the sun's own stream of harmful particles. It is the Earth's magnetic field, generated by the motion of liquid iron in our planet's outer core. This magnetic field extends far out into space, creating a protective bubble around our world called the magnetosphere. It deflects and traps most of the dangerous high-energy particles, guiding them away from the surface, a gentle, invisible bubble of safety that makes life on Earth possible. When particles from the sun, a stream called the solar wind, interact with our planet's magnetic field, they can create a beautiful and ethereal light show near the poles. The magnetic field funnels some of these energetic particles down towards the Earth's north and south magnetic poles. There, they collide with the atoms of oxygen and nitrogen in our upper atmosphere, causing those atoms to become excited and then to glow with soft light. This creates the beautiful shimmering curtains of green, pink, and violet light we call the auroras, the northern and southern lights, a silent, dancing spectacle of cosmic energy made visible. Our sun is not always a calm and steady star. It goes through cycles of activity that last about 11 years from peak to peak. During the peak of this cycle, which is called the solar maximum, the sun's surface becomes mottled with dark patches called sunspots. These are not holes, but are actually cooler areas on the sun's surface, though they are still incredibly hot. They are caused by intense, tangled magnetic fields that poke through the surface, inhibiting the flow of heat from below, creating temporary dark blemishes on the face of our star. Sometimes, the powerful magnetic fields around these sunspots become twisted and strained, like a rubber band being stretched too far. Eventually, they can suddenly snap and reconnect into a simpler shape, releasing a huge and violent burst of energy. This is called a solar flare. It sends a powerful wave of radiation and charged particles out into space at incredible speeds. If a large flare is aimed at Earth, it can cause beautiful auroras. but it can also disrupt satellites, radio communications, and power grids. A sudden, powerful storm from our life-giving star. Out in the wider, colder universe, there are planets that do not orbit a star at all. These are called rogue planets, or orphan planets. They were likely formed in a solar system just like any other, but were then ejected from their home system by the chaotic gravitational pull of other, larger planets during its early history. They now wander through the cold darkness of interstellar space, alone and untethered, not bound to any star. They are dark, frozen worlds, their only source of heat coming from their own cooling cores. Silent, lost children of the galaxy, drifting forever in the night. There are also planets that have more than one sun. Some planets have been found orbiting two stars at once. These are called circumbinary planets, like the fictional planet Tatooine from the movie Star Wars. From the surface of such a world, you would see two suns in the sky. They might be different sizes and different colors, perhaps a large yellow sun and a smaller red one. They would rise and set at different times, creating strange and beautiful double sunrises and double sunsets, a sky unlike any we have ever known, a world with two shadows. Some of the distant planets we have discovered, which are called exoplanets, might be covered entirely in water. These are hypothetical worlds called ocean worlds. They could have deep, global oceans, hundreds of kilometers deep, with no land at all. The pressure at the bottom of such an ocean would be immense, possibly creating strange forms of high-pressure ice that are hot to the touch. In the dark, deep waters of these worlds, warmed by heat from their cores, it is possible that strange forms of life could exist, completely independent of a sun's light, a hidden biosphere in the deep dark. We search for life on other worlds by looking for a special region around each star. It is called the habitable zone, or, more playfully, the Goldilocks zone. This is the orbital area where the temperature from the star is just right, not too hot and not too cold, for liquid water to exist on a rocky planet's surface. Water is essential for life as we know it, so planets found in this gentle region of possibility are our best candidates for finding life beyond Earth. It is a cosmic shoreline, a temperate band of orbits where life might take hold and flourish. The first planet to be confirmed orbiting a sun-like star outside our solar system was only discovered in 1995. For all of human history before that, we only knew of the 8 planets in our own family. But since then, using powerful instruments like the Kepler Space Telescope and the TESS satellite, we have discovered thousands of them. Each new discovery tells us that planets are not rare. They are common. It seems that most stars have planets orbiting them. This suggests that our solar system is not unique, a comforting thought that we may not be alone in the vast starry darkness. Let us return now to our own solar system, to the family of worlds we know best. Jupiter is the king of the planets, the largest and most massive in our solar system. It is a gas giant, made mostly of hydrogen and helium, with no solid surface to stand on. It is so big that all the other planets, Mercury, Venus, Earth, Mars, Saturn, Uranus, and Neptune, could all fit inside it at the same time. Its immense gravity has shaped our solar system, acting as a cosmic bodyguard, deflecting many comets and asteroids that might otherwise have hit Earth. Jupiter has a famous and mysterious feature, the Great Red Spot. It is a giant, swirling storm, a persistent anticyclonic hurricane larger than the entire planet Earth. It has been raging continuously for at least 300 years, since telescopes were first able to see it, and possibly much longer. The winds inside this storm can reach hundreds of kilometers per hour. We still do not fully understand what gives it its deep red color, or what has kept it going for so long. It is a swirling crimson eye that stares out into the cold of space, a permanent storm on a world of storms. Saturn is perhaps the most beautiful planet in our solar system, known for its stunning and iconic rings. These rings are not solid, but are made of billions upon billions of small pieces of ice and rock. Some of these pieces are as small as a grain of dust, while others are as large as a house, or even a small mountain. They all orbit Saturn together in a thin plane, forming a vast, glittering river of ice, a delicate and shimmering disk that reflects the distant sunlight, a cosmic jewel in the night. The rings of Saturn are incredibly wide, stretching out for hundreds of thousands of kilometers, but they are also incredibly thin. In most places, the main rings are only about 10 meters, or 30 feet, thick from top to bottom. If you were to build a scale model of Saturn that was 1 yard wide, its rings would be many thousands of times thinner than a single sheet of paper. They are a delicate, fragile-looking structure, a testament to the strange and beautiful forms that gravity can create. A razor-thin sheet of shimmering ice, held in a perfect, silent orbit. Uranus is a strange and tilted planet, a true oddball in our solar system. While most planets spin like a top as they orbit the Sun, with their poles pointing mostly up and down, Uranus is tilted on its side by almost 98 degrees. It essentially orbits the Sun like a rolling ball. This extreme tilt is likely the result of a massive collision with another large body early in its history. This tilt creates a world of the most extreme and bizarre seasons imaginable. A planet that rolls through its long 84-year orbit. Neptune is the most distant major planet from the Sun, a cold, dark, and deep blue world. It is an ice giant with a thick atmosphere of hydrogen, helium, and methane gas, which absorbs red light and reflects blue light, giving the planet its rich, beautiful color. Neptune is a world of incredible winds. It has the fastest winds in the entire solar system, which have been measured at speeds of over 2,000 kilometers per hour, faster than the speed of sound. These are silent, supersonic storms, whipping through the deep blue atmosphere of a world at the edge of the sunlight, a place of deep cold and incredible speed. The smaller rocky planets have their own quiet wonders. Mars, the red planet, is home to the largest volcano in the entire solar system. It is called Olympus Mons. It is a type of volcano called a shield volcano, built up by slow, repeated flows of lava over a very long time. It is 3 times taller than Mount Everest, and it is so wide that it would cover the entire state of Arizona. It is a sleeping giant on a red world, a silent monument to a time when Mars was more geologically active, a mountain so large you could not see its peak from its base. Venus is a world of extreme and suffocating heat. It is the hottest planet in our solar system, even hotter than Mercury, which is much closer to the Sun. This is because of its thick, dense atmosphere, which is made almost entirely of carbon dioxide with clouds of sulfuric acid. This atmosphere acts like a thick blanket, trapping the Sun's heat in a runaway greenhouse effect. The surface temperature is hot enough to melt lead, and the atmospheric pressure is the same as being a kilometer deep in Earth's oceans, a toxic, hellish world, hidden beneath beautiful, pale yellow clouds. A day on Venus is longer than its year. a strange and counterintuitive fact that speaks to its bizarre nature. It spins on its axis very, very slowly, and it spins in the opposite direction to most other planets, a motion called retrograde rotation. A single day on Venus, from one sunrise to the next, takes 243 Earth days to complete, but it only takes 225 Earth days for Venus to complete one orbit around the Sun, so its day is longer than its year, a slow, backward, lazy world where time passes in a very different and sleepy way. Mercury is the closest planet to the Sun, and also the smallest major planet in our solar system. It has almost no atmosphere to speak of, just a very thin, wispy layer of atoms called an exosphere. Without an atmosphere to protect it, or weather to erode its features, its surface is covered in craters from billions of years of impacts by asteroids and comets. It looks very much like our own moon, a silent, pockmarked world that is baked by the intense heat of the nearby sun during its day, and then freezes in the deep cold of space during its long night. Our own moon has a dramatic and violent origin story. It was likely formed from a great impact, very early in the solar system's history. The most popular theory suggests that a protoplanet, about the size of Mars, which scientists have named Theia, collided with the very young Earth. The incredible energy of this collision melted both bodies and threw a huge amount of molten rock and debris into orbit around the Earth. This ring of debris then slowly came together under its own gravity to form the Moon, our constant companion, a child born from a cosmic crash. The Moon is slowly, very slowly, moving away from the Earth. It drifts away from us at a rate of about 4 centimeters, or 1.5 inches, every single year. This is about the same speed that your fingernails grow. This slow retreat is caused by the transfer of rotational energy from the Earth to the Moon through tidal forces. This means that in the distant past, the Moon was much closer to the Earth and would have appeared much, much larger in our sky. And in the far, far future, it will be more distant and appear smaller, a slow and steady retreat that has been happening for billions of years. There is no permanent dark side of the Moon. This is a common and understandable misconception. The Moon is tidally locked to the Earth, which means it rotates on its axis in the exact same amount of time it takes to orbit the Earth. This is why we only ever see one face of the Moon from our perspective. But as the Moon orbits the Earth, all of its sides get sunlight at some point. The side we cannot see from Earth is more accurately called the far side. It is just as bright when the sun shines on it, and just as dark during its long lunar night. A hidden face, not a permanently dark one. We have found water on the Moon, not as oceans, rivers, or even puddles, but as ice, frozen solid in the bottom of deep craters near the Moon's poles. These craters are in areas that are permanently in shadow. The sunlight never reaches their floors, and so they have remained incredibly cold for billions of years. They act as cold traps that can preserve water ice over geologic time. This hidden reservoir of frozen water could be a vital resource for future human exploration of the Moon, a precious substance hiding in the eternal darkness of a crater floor. The many stars you see in the night sky have different colors, if you look closely on a clear, dark night. This color is a direct clue to a star's surface temperature. The hottest stars are a brilliant blue or blue-white, while the coolest stars are a dim orange or red. Our own yellow sun is somewhere in the middle of this temperature range. The sky is a gentle rainbow of stellar fires. from the blue-white heat of Rigel to the deep red of Betelgeuse, each color telling a quiet story about the star's age, mass, and temperature. A beautiful diversity in the cosmic garden. Many of the points of light we see as single stars are not alone at all. More than half of all stars exist in pairs, or even in groups of 3 or more, all orbiting a common center of gravity. These are called binary or multiple star systems. It is like they are partners in a long, slow dance, held together by the invisible thread of their mutual gravity. This silent dance can last for billions of years, as the stars weave intricate, looping patterns through space, cosmic companions on a long journey through the night. Sometimes in these binary systems, one star can pull material from its companion, creating a dramatic cosmic interaction. If one star in the pair is a very dense object, like a white dwarf or a neutron star, its powerful gravity can strip gas, mostly hydrogen, from the outer layers of its larger, more bloated partner star. This gas then falls towards the smaller, denser star, forming a hot, glowing disk around it called an accretion disk. This process can cause the white dwarf to flare up in bright explosions called novae, a stellar vampire, feeding on its partner in the dark. Nebulae are the birthplaces of stars. They are vast, beautiful clouds of gas and dust that float in the space between stars. Some of them, called emission nebulae, glow with brilliant colors, as the intense ultraviolet light from young, hot stars inside them excites the gas and causes it to shine, like a cosmic neon sign. Others are dark nebulae, and we only see them as black silhouettes against the brighter stars or glowing nebulae behind them. They are the stellar nurseries of our galaxy, where the raw materials for new suns and new worlds are slowly gathering, a quiet cosmic womb. Not all clouds of gas are massive enough to become stars. Some clumps of gas and dust begin to collapse under their own gravity and start to heat up, but they never get quite hot enough in their cores to begin the process of nuclear fusion. These are called brown dwarfs, or failed stars. They are larger than a planet like Jupiter, but smaller than a true star. They glow dimly with their own internal heat, a faint, deep red or magenta color. But they are not true suns. They are silent, warm wanderers, stuck in the twilight between a planet and a star. The space between the stars, the interstellar medium, is not just empty. It is filled with a very thin mixture of gas, mostly hydrogen, and tiny solid particles of dust. This dust is made of carbon, silicon, and other elements forged in older stars and blown out into space. Though it is incredibly sparse, over vast distances, this dust can block and scatter the light from stars behind it, making parts of our galaxy appear dark and creating beautiful reflection nebulae. It is this same dust that eventually clumps together to form new planets and new life. It is the raw material of creation, floating silently in the void. One of the most powerful and terrifying events in the universe is a gamma-ray burst. For a few brief seconds, or sometimes a few minutes, a point in the sky can light up with a blast of high-energy gamma rays, outshining everything else in the universe combined during its short life. These are the most powerful explosions we know of, and they come from very far away, often from the edge of the observable universe. We believe they are caused by the collapse of a very massive star into a black hole, or the merger of two neutron stars, a final, incredibly powerful scream that travels across the cosmos for billions of years. There is a special and very strange kind of neutron star called a magnetar. These are neutron stars with magnetic fields that are unimaginably strong, 1,000 trillion times stronger than Earth's own magnetic field. This magnetic field is so powerful that it can buckle the star's solid crust, causing starquakes. These starquakes release huge bursts of energy, mostly as X-rays and gamma rays. A magnetar is a tiny, city-sized object, with a magnetic power so great it could wipe a credit card from halfway to the moon, a small star with a terrifyingly powerful heart. Our galaxy is not just moving, it is being pulled. The Milky Way, our neighbor Andromeda, and all the other galaxies in our local supercluster are all being drawn towards a mysterious and unseen point in space. This point is called the Great Attractor. It is a gravitational anomaly, a huge concentration of mass that lies about 250 million light-years away. We cannot see it directly because it is hidden from our view by the dust and stars in the plane of our own galaxy, but we can see its powerful gravitational pull on everything around it, a silent, invisible river pulling us towards an unknown destination. Just as there are great clusters of galaxies, there are also great empty spaces in the universe. The largest of these is called the Buddha's Void. It is a huge, almost perfectly empty region of space, nearly 330 million light-years in diameter. While it is not a perfect vacuum, it contains very, very few galaxies, far fewer than would be expected for a space of its size. If our galaxy were at the center of this void, we would not have known other galaxies existed until the 1960s. It is a great cosmic desert, a place of profound and unsettling emptiness, a quiet island of nothingness in the cosmic sea. One of the most exciting places to search for life in our own solar system is not a planet, but a moon, Jupiter's moon. Europa is covered in a thick shell of water ice that is miles deep. Beneath this ice, there is strong evidence for a vast global ocean of liquid salt water. This ocean may be kept liquid by heat generated from the tidal forces of Jupiter's immense gravity stretching and squeezing the moon's interior. It is possible that this dark, deep, hidden ocean could harbor life, perhaps clustered around hydrothermal vents on the seafloor, a secret world hidden beneath a shell of ice. Another fascinating moon is Saturn's largest moon, Titan. It is the only moon in our solar system with a thick, dense atmosphere, even thicker than Earth's, but its atmosphere is made of nitrogen and methane, and it is incredibly cold. The surface of Titan is a strange alien landscape with rivers, lakes, and seas. But these are not made of water. They are made of liquid methane and ethane. It rains liquid methane from the orange sky, and it flows into vast, dark seas, a cold, slow, and alien version of the water cycle on Earth, a strange mirror to our own world. And what is the ultimate fate of our universe? In the far, far future, trillions upon trillions of years from now, if the universe continues to expand and accelerate as it is doing now, it will face a quiet and peaceful end. It is a fate known as the heat death. All the stars will have burned out, becoming cold black dwarfs, neutron stars, and black holes. The universe will become darker and colder and emptier. Eventually, even the black holes themselves will evaporate over unimaginable timescales, leaving behind only a faint, cold mist of particles, a final, silent, and eternal state of perfect equilibrium. In all this vastness, in all this incredible motion and scale, there is no true center to the universe. because space itself is expanding everywhere at once. Every point can be considered the center of its own observable universe. From any galaxy you choose, it would look like all other galaxies are moving away from you. There is no special place, no privileged position in the cosmos. It is a universe with 1 trillion centers, and no single one at all. A humbling thought that makes every point both the center and the edge of everything. When astronauts are in orbit and they look down at the Earth from the window of their spacecraft, they often experience a profound and transformative feeling. This is called the overview effect, seeing our world as a single, small, fragile ball of life. A blue and white marble hanging in the blackness of space can change a person's perspective forever. National borders disappear, and the interconnectedness of all life becomes clear and obvious. It is a feeling of deep awe and a sense of unity with the whole of humanity and with the planet itself, a quiet moment of clarity. The universe has been here for about 13.8 billion years. It is a time scale that is difficult for a human mind to truly comprehend. If you were to compress that entire history into a single calendar year, the Big Bang would happen at the first instant of January 1st. The Milky Way galaxy would form in May. Our solar system would appear in early September. The first life on Earth would arise in late September. Dinosaurs would walk the Earth in the last week of December. And all of recorded human history would take place in the last 10 seconds, before midnight, on December 31st. Our own story is just a tiny flicker in the last moment of this cosmic year. If you enjoyed this quiet journey, I am glad you found your way here. It helps others find this peaceful corner too, one sleepy soul at a time. And now, just breathe, let your eyes close, and let the quiet stars lull your thoughts to sleep. Good night.